What is Write Data by Identifier? This service allows a diagnostic client to write data into the internal memory of the server. Hello and welcome back to Autoslearn. In the last video, we looked at the Read Data by Periodic Identifier service, also known as the 2A Diagnostic Service. Today, let's move on and explore another important UDS service, Write Data by Identifier, also called Service 2E. What is Write Data by Identifier? This service allows a diagnostic client to write data into the internal memory of the server. The data is identified using a special code called the Data Identifier or DID. This is useful when updating configuration settings or runtime values, especially during diagnostics or development. Common use cases include programming configuration data like the VIN number, clearing non-volatile memory, resetting learned values, setting option content, and much more. But remember, not all DIDs are writable. Some are marked read-only by the system supplier or the vehicle manufacturer. If you try to write to these, the server will respond with a negative response. Let's now look at the request format. The Write Data by Identifier request is made up of three parts. First, the service ID, which is 2E. Second, the data identifier or DID, for example F190. Third, the data record, which is the actual value to be written, formatted according to the DID. Positive response. If the request is successful, the server replies with a response service ID of 6E and the same DID that was sent in the request. Negative response codes. If the request fails, the server will send a negative response. This includes a specific code called a negative response code or NRC. Here are some common NRCs. NRC 13, incorrect message length or invalid format. This means the message was too short or badly structured. NRC 22, condition not correct. This happens when the condition is not correct. For example, the ignition might be off or the voltage level may be out of range. NRC 31, request out of range. This happens when the DID is not writable or it's marked read-only. NRC 33, security access denied. This means the operation is blocked until the correct security level is unlocked. NRC 72, general programming failure. This indicates an error occurred while writing to memory. Let's look at how the server decides which NRC to send. Let's go step by step. Firstly, message length check. If the message is too short, then NRC 13 shall be returned. Next, the server performs session check. If the DID is not allowed in the current session, then NRC 31 shall be returned. Next, the server performs expected length check. If the data length is wrong, then again NRC 13 shall be returned. Next, the server performs security access check. If the session is locked, then NRC 33 shall be returned. Next, the server performs preconditions check. If ignition or voltage conditions are not met, then NRC 22 shall be returned. Next, the server performs data validation. If the data format or content is invalid, then NRC 31 shall be returned. Next, the server performs memory write check. If writing to memory fails, then NRC 72 shall be returned. If all checks pass, the server sends a positive response confirming that the data was written. Let's look at an example such as writing the VIN number. Let's say the client wants to write the VIN, which is usually mapped to DID F190. the request would look like this. Client request 2E F190 followed by the VIN data. Server response 6E F190. This tells us that the server accepted and completed the write operation. And that wraps up our explanation of the write data by identifier service or service 2E. In the next video, we'll explore another powerful UDS service, write data by address, also known as service 3D. If you found this helpful, be sure to like, subscribe, and share with your fellow automotive tech enthusiasts. Thanks for watching Autoslearn.